Hello, and welcome to the AI Research Roundup. I'm Alex, and today is May 7th, 2025. Alright, today we're looking at an ICLR conference paper titled, Navigating the Digital World as Humans Do, Universal Visual Grounding for GUI Agents, published on January 22nd, 2025. So, a little over 3 months ago. This paper explores how AI agents, programs that use graphical user interfaces, or GUIs, can interact with screens more like humans do. Instead of relying on text descriptions from code, which can be messy, the goal is for agents to see the graphical user interface visually and act at the pixel level, interacting with the screen's tiny dots. The main challenge is robust visual grounding, accurately mapping instructions to screen locations. Alright, so this figure here really sets the stage. On the left, we see examples of tasks these agents might perform on different platforms, like finding a trade-in value on a website. Then, on the right, there's a radar chart. This chart compares their new model, UGround, shown in yellow, against previous top methods, what's known as prior state-of-the-art, or SOTA, shown in red. UGround consistently shows better results across many different benchmarks, which are standardized tests, especially for that visual grounding capability, helping agents accurately link instructions to screen locations. Okay, so building on that improved visual grounding, this next figure really illustrates their CACTV framework, which is the vision-only system they developed. It shows a 3-step process. First, vision-only observation, where the agent gets a task, like find the cheapest 4K monitor, and just sees the screen. Then, planning, where an AI model decides the next action, say, identifying the search bar at the top of the page. The crucial grounding step then uses this referring expression, that descriptive phrase, to pinpoint the element's exact pixel coordinates, its x, y location on the screen. Finally, human-like operation shows the agent actually clicking and typing at those coordinates. So following that CACTV process, this figure provides some really clear examples of those referring expressions, the descriptive phrases we talked about, which are vital for the grounding step. It shows how an element, like the Uniqlo logo, can be described visually, for instance, red icon labeled Uniqlo positionally, button at the top left corner, or even by its function, navigate back to the home page. UGround's ability to understand this rich variety of human-like descriptions, thanks to its training on diverse synthetic data, is key to its success in accurately locating elements. Now, to achieve that impressive understanding of varied descriptions, this table gives us an overview of the training datasets used for UGround. You can see their own web hybrid dataset is massive, 9 million elements from over 770,000 screenshots. This data was annotated using rules and a large language model, or LLM, an AI trained on vast amounts of text to understand and generate human-like language. This sheer volume and diversity of data, combining web and Android platforms, are really what powers UGround's ability to accurately locate screen elements using those rich descriptions. Alright, so after training with all that diverse data, this table really shows the payoff. It details the grounding accuracy, essentially how well the model finds the right spot on the screen, on a specific test called the Screen Spot Benchmark. We can see UGround, their model, compared to others like GPT-4 and CClick. Across mobile, desktop, and web platforms, and for both text elements and icons or widgets, UGround consistently scores higher. Its average accuracy hits 73.3%, which is a significant leap, about 20% better than the next best, CClick, demonstrating really strong visual grounding. Okay, so building on its strong performance in the standard ScreenSpot benchmark, this table shows UGround's grounding accuracy in what's called an agent setting. Here, the referring expressions, those crucial element descriptions, are generated by an AI planner, like GPT-4 or the newer GPT-4o. Across mobile, desktop, and web platforms, UGround consistently outperforms the CClick model. When combined with GPT-4o as the planner, UGround reaches an impressive 81.4% average accuracy. This result is a big jump, further highlighting UGround's robustness when working with AI-generated instructions for real-world agent tasks. Following UGround's strong showing with AI planners, this figure really digs into how it achieves that. We're looking at a scaling curve here, which is just a graph showing how UGround's performance on the ScreenSpot benchmark changes as the amount of its web hybrid training data increases, specifically the number of screenshots. As more screenshots are used for training, from 50,000 up to over 770,000, the accuracy generally climbs, especially on mobile. This upward trend, consistently outperforming the baseline C-click model shown by the dashed line, really highlights the power of that large, diverse dataset we discussed. So that scaling curve really underscores a core idea here. The more diverse web-based data UGround is trained on, the better it gets at visual grounding, which, as we've discussed, is all about accurately finding elements on a screen using descriptions. This research makes a strong case that graphical user interface agents, these are AIs that interact with computers visually much like humans do, can indeed operate effectively using only what they see. UGround's impressive ability to understand where things are is really paving the way. Thanks for tuning into the AI Research Roundup. I'm Alex.